rolling. To understand the concept of rolling, let us consider a metal piece and pass it through two rollers rotating in opposite directions. The speeds of both these rollers are uniform and equal. When we insert the metal plate between the rollers, we see that the rollers squeeze the plate as they pass through them, transforming it to a sheet by decreasing its thickness and increasing its length. During this process, grains present in the metal plate get elongated. Now let us focus on the area of contact of the plate and the rollers. For better analyzing, let us divide this area into two parts, part 1 and 2 as shown. Let us assume the velocity of rollers be Vr and the velocity with which the metal plate enters and exits be V0 and Vf respectively. We see that the metal first travels at a slow speed and then gains speed as it passes through the rollers. That is, V0 is smaller and Vf is greater than Vr. Thus, the velocity distribution curve can be drawn as: in the first part, frictional force acts in the direction of the metal sheet, while in the second part, frictional force acts in the reverse direction. At the interface of these two parts, speed of the metal plate is equal to the speed of rollers. This point is known as no-slip point. Here, the metal plate changes to sheet with increased length and decreased thickness with the help of rollers. Thus, the process of compressing a metal between two rotating rolls for reducing its thickness and increasing its length is called as rolling. Mathematically, the rolling power required per roll is given as, where F is the roll force, L is the roll strip contact length, and N is the speed of roll. Manufacture of railway tracks is the most common application of rolling. Note that the angle subtended at the center of the roll by the roll strip contact length is called angle of contact or maximum angle of bite. Related terms are